students, I welcome you to this material science class, and today we are going to concentrate over the various aspects like recrystallization and its consecutive effects. Whenever a metal is heated, its atomic structure changes. Internally, some changes are taking place in the atom, which is called as recrystallization. Generally, recrystallization occurs in the temperature range of 0.3 Tm to 0.5 Tm, 0.3 times melting point. That's the beginning of the change of recrystallization structure. It's called as beginning of recrystallization. And the recrystallization ends at 0.5 times melting point of the metal. So this change is called as recrystallization range. So after the recrystallization range, above 0.5 times the melting point, its properties may be varied. So during the recrystallization change, during the recrystallization range, some atomic arrangements are changed and hence some properties may be varied. So grain size may be varied. It's called as grain growth. Whenever the grain sizes are varied in a particular direction, it's called preferred orient direction. If the temperature is less, below 0.5 Tm, then temporarily some changes may take place, but the changes will be disappeared, and the material may regain its original properties. So in such case, it is recovering the original aspects, the recovery. And whenever the material is heated to a particular temperature below the recrystallization level, that means 0.3 times melting point of the metal, then the metal may be formed into different shapes by applying different forces. In that case, it is called cold working. So cold doesn't mean very low temperature, but it means less than 0.3 times melting point. That means it's less than the beginning of recrystallization. So recrystallization does not occur, but the body is heated and some force is applied. So its size may be changed. There may be some variation, but the original atomic structure can be obtained because of temperature is less than 0.3 times melting point. But due to this cold working process, the strength may be increased, the fatigue strength may be increased, tensile strength may be increased. There are some increase in strength. It's called strengthening mechanism, particularly by heating the metal to below 0.3 times melting point, and if it is applied by some force and the force is continuously applied for a particular timing, 6 hours or 7 hours, it's called as strain hardening or work hardening. The examination said short notes on strain hardening or work hardening may be asked. So it's a cold working process. This process also called strengthening because of increasing the strength, and also due to this cold working process, better surface finish can be obtained. Better dimensional control can be obtained during the deformation, and the materials have more resistance to fatigue and suddenly applied force. The directional properties may be imparted. These are the various characteristics of cold working. Therefore, during the cold working, the force required for change of size may be large. So more force is required, and powerful equipment. The equipment should have more power to deform the metal. So powerful equipment is required, and undesirable residual distress may be produced at low level. These are the important things in the case of cold working. And if it is more than 0.5 times melting point, it's called hot working. If it is between 0.3 times melting point to 0.5 times melting point, it's called warm working. Warm working, it has more temperature than that of cold working. So it results in less force than that of the cold working process to form the metal to different shape. And when it's compared to this cold working, some amount of heat energy is imparted, and for better precision of components, for better accurate level of deformation, this warm working may be desired. So by warm working, better dimensional control can be obtained. Better surface finish can be obtained, and there may be thermal shock may be less. There may be thermal fatigue may be less. But in the case of hot working process, plastic deformation takes place at high temperature, more than 0.5 times melting point. So recrystallization takes place, crystal structure change takes place, and therefore properties may be varied. And ductility property, the property by which the material can be elongated as a thin wire or thin rod, that's called as ductility. The property will be improved due to hot working process, since it's heated to high temperature. And malleability may be increased, but there's no strain hardening. Less force is enough to deform the metals, since the temperature is more, and the equipment required for this process for forming the different metal to different shape may be having less power. These are the various characteristics of hot working. But more heat is required. Surface finish may be poor due to this more heat, and due to at high temperature the gases may escape out, so then pores may be formed, and accuracy may be affected. Dimensional control may be affected. Also handling and maintaining of the hot metal may be difficult. These are the various aspects of hot working. So you may be asked to compare the cold working process and hot working process. Comparison is quite often asked in the exam between the cold working process and hot working process. The temperature is below recrystallization temperature in the case of cold working. In the case of hot working, the temperature is more than the recrystallization temperature. And in the cold working process, better surface finish can be obtained. In the case of hot working, surface finish may be less. And in the case of cold working process, the other mechanical properties like the elongation, ductility, malleability, and such things may be decreased, whereas the ductility, malleability, such things are increased in the case of hot working process, and crystallization does not take place in the case of cold working process, and crystallization takes place in the case of hot working process. And in the case of hot working, the metal is deformed uniformly because of high temperature. But cold working, you cannot expect that. And in the case of hot working, due to high temperature, homogeneity can be obtained. Whereas in the cold working process, homogeneity cannot be obtained. And due to homogeneity, there will be less risk of cracks in the case of hot working. But in the case of cold working, there will be more risk of cracks. And in the case of hot working, thermal stress may be induced. But in the case of cold working, thermal stress is not induced. Cold working requires more energy for performing its operation. Hot working, it does not require more energy for its operation. So these are the various points in comparison between the cold working and hot working. So whenever the deformation of the metal depends upon the rate of change of stress, then the property is called as anelasticity. And in the case of liquid, like water, oil and so on, there may be some resistance to shear force or shear stress. So by that property, it may flow slowly like honey, the property by which it resists the shear force or shear stress. The property is called viscosity. And by this property, viscosity, and since it's viscous, whenever the external force is applied on it, it resists the external force. It's called viscoelasticity. So by this property may be used for reducing the shock, reducing the vibrations. And this property is used in shock absorber by oil, and the external force will be reduced in the case of solid by spring. The spring and the container containing oil is called dashpot. The spring and dashpot are maybe connected in series, that may be used for resisting the shock. That case is called a Maxwell model. Maxwell has formed this model. And whenever the spring and dashpot are connected in parallel, and this parallel arrangement is used for reducing the shock, it is called a Kelvin model. So these are the various models which are used in engineering field. And whenever force is applied, stress is developed. By the stress, strain is caused, the elongation is caused, the body gets deformed in its dimensions. Therefore, the strain is always lagging behind the stress. Whenever stress force is applied, stress takes place and it varies quickly, whereas the strain, that is the change of dimensions or deformation of the metal, it changes slowly, it follows the stress. This lagging of strain behind the stress is called as passengers of it. Passenger has found this, so it's called passengers of it. Passenger has drawn certain curve to explain the variation of stress with respect to strain, and he has concluded the strain lags behind stress. It's called passengers of it. So these are the various aspects in plastic deformation. In the examination, they will be asked short notes or comparison. So revise all these things. Go through your notes. If you got any doubt, just contact me. Thank you.